Hello everyone, the power of pi here, and today we're going to be looking at something different, kind of like a classification model called the naive Bayes model. So this is essentially a probability model that hinges on the Bayes theorem, and I'll be giving a brief introduction in this video. So conditional probability, first of all, is essentially regular probability, except that we're kind of like chopping off space and we're just looking at a single like sample space. So we'd say that probability of A given B is equal to the probability of A and B happening over the probability of B. So essentially the sample space is now just probability of B, and then from there you just want to find when probability of A and B happens. So that's like one equation. Another one would be if we switch around B and A, this is probability, again, A intersection B. B intersection A and A intersection B are the same thing. And then over probability of A. So this is a second equation. So now let me just use a second equation. The probability of A union B is equal to probability of A times the probability of B given A. So with this, I can now plug this. I can now plug this third equation to the first equation to get P of A given B is equal to P of A times P of B given A over probability of B. And then this is known as Bayes' theorem. So this is basically the theorem that the model is built off of. So let's just reiterate it. So for random variables x and y, we have the probability of x given y is the probability of x times the probability of y given x over probability of y. Okay, so now how is this model kind of created? So if we let x be the random variable that can take on values x1, x2, all the way to xn, and we let y equal the random variable that can take on variables y1, y1, all the way to like some yk. Now, if you wanted to ask a question such that, what is the maximum value such that probability of, what is the value of y such that probability of y given x is equal to x1, x2, xn is maximal? That would be an example of a naive Bayes theorem, naive Bayes classification. So there's one way to do it in where we essentially like search all n columns of our data and then like count up successes in total. For example, probability of x given y is hard to find. We just look at the probability of y given x. We'll see for what values of y does the corresponding x's match over all possible values of x. But then there's also an easier way. For example, if we have a large number, x and y can take on many values. For example, like 100 million values. Then what we can do is something naive, which is basically where the naive Bayes model comes from. We can say that xi's are independent. This hinges on the fact that we can treat the xi's as independent, which will obviously never be true. Very rarely be true. So if the xi's are independent, we can say the probability of y given x is equal to x1, x2, all the way to xn is really just equal to the probability of y given x1 times the probability of y given x2, all the way to probability of y given xn. So in kind of compact notation, we can say this is equal to the product from I equals 1 to n of p of y given xi. So this is kind of helpful. So instead of searching like the 50 million rows to find a hit, basically all we do is we search one of the x's and then our y, and then the other, and then the y, and then we multiply them all together, and it's a little bit more convenient for us. So y given xi. So instead of this, we use this. So that's the fundamentals of the naive Bayes model. If you're interested in seeing more of this, make sure to like and subscribe, and I'll see you guys in the next video.